Welcome back for part 3 and the last part of our lecture today. I know that this is long. Thanks for bearing with me. Our last part is converting between our two coordinate systems, our polar coordinate system and our rectangular or our Cartesian coordinate system. So let's say that we have the point P, and this point, its polar coordinates are r comma theta, and its rectangular coordinates are x comma y. Then they relate in these ways. Its x coordinate is equal to r times its cosine of theta, and y is equal to r times the sine of theta. This might seem familiar from our vectors component form. It's almost like we learned that for a reason. I know, shocking. And then x squared plus y squared is equal to r squared, and tangent of theta is equal to y over x. So you use these to find rectangular form, and you use these to find polar form. So again, these might look kind of familiar as well, because the square root of x squared plus y squared is equal to the magnitude of a vector, and then tan inverse of y over x was equal to the direction of the vector. I know, it's all coming back. So worth learning that. All right, so if you're going to put anything from this lecture into your notes, I would put this in, that when we have polar and we're going to Cartesian, I'm going to say rectangular because if I'm being totally honest, I don't think I can spell Cartesian off the top of my head. Rectangular, that's why I don't teach English. All right, polar to rectangular. Our point is going to be r cosine of theta, comma r sine of theta. So when you are in your polar coordinates, you have r and theta, and then to get to rectangular, you do r times cosine of theta, comma r sine of theta. And then if we want to get to, or if we're in rectangular, so we have x and y, rectangular, and we want to go to our polar, then our radius, our r, is going to be the square root of x squared plus y squared, and then our angle theta is going to be tan inverse of y over x. So all of this should look fairly familiar from the unit that we just did on vectors, but let's put it into practice here. All right, so for letter A here, we want to convert this to rectangular coordinates. So first thing to notice, this right here is a unit circle angle. So unit circle angle, you don't need to use your calculator. So converting this, we are going to have, this is r, this is theta. We have r, 3 times the cosine of 5 pi over 6, and then 3 times the sine of 5 pi over 6. So using our knowledge of the unit circle, we know that our cosine of 5 pi over 6 is equal to negative root 3 over 2. And then the sine of 5 pi over 6 is equal to 1/2. So our final answer is going to be negative 3 root 3 over 2. It's my x coordinate. And then my y coordinate is going to be 3/2. So this is x and this is y. All right, now for this one here, this is not a unit circle angle. Not unit circle. So I don't know about you guys, but I don't know the cosine and sine of negative 200 off the top of my head, so you have to use a calculator. So going through this same process that we did up here, we're going to take our r, so 2 times the cosine of negative 200, and then 2 times the sine of negative 200. So like I said, I don't know those off the top of my head, but I already did this math out, and you should end up with negative 1.88 and 0.68. So this gives you an x and a y. All right, so guided practice right here. I want you guys to pause the video, give these a whirl, see what you come up with, and then we will go through them together. All right, first one. Going through this, we have 6 cosine 7 pi over 4, comma 6 sine of 7 pi over 4. And we know that we have 6. The cosine of 7 pi over 4 is positive root 2 over 2. And then the sine of 6 pi over 4 is negative root 2 over 2. So we have 6 times negative root 2 over 2. Simplifying this down, we can cancel this, get a 3, cancel this, get a 3, negative 3, because this is negative. So our final answer is going to be 3 square root of 2, comma, negative 3 square root of 2. So this is my x and my y. And then last but not least, for this one, I'm going to do this work over here so it doesn't get scrunched. We have 2 cosine of negative 5 pi over 3. Should be negative 2 sine of negative 5 pi over 3. And then cosine of negative 5 pi over 3. So this is pi over 3. So 2 times that cosine, or cosine of pi over 3, is 1/2. And then 2 times the sine of pi over 3 is root 3 over 2. 2's all cancel, so my final answer is 1, comma, square root of 3. This gives me an x and a y. So now we've gone from polar to rectangular. Now we're going to go from rectangular to polar. So we have this point here, negative 1, 1. So thinking back to Cartesian and rectangular coordinates, this is my x coordinate, this is my y coordinate. So I go over 1, up 1. So I'm right here. And this is going to be important. Remember, you are in quadrant 2. So we are trying to find the polar coordinate. So how far away it is from the center. That was another fairly good circle, if I do say so myself. So we want to find this distance r, and then this angle theta. So to do that, we have to find our r, which is equal to the square root of x squared plus y squared. Y is equal to 1. So this is going to be the square root of 1 plus 1, so square root of 2. And then theta is equal to tan inverse of negative 1 over 1. So tan inverse of negative 1. This is where it becomes important that we are in quadrant 2, because if you type into your calculator tan inverse of negative 1, it will spit out at you a negative angle that is in quadrant 4 because of our restrictions on our inverse tangent. So since we know we're in quadrant 2, and we know this is a unit circle angle where our tangent is equal to negative 1. Think all the way back to the unit circle. Tangent is equal to positive or negative 1 at our pi over 4 reference angles. So our pi over 4 reference angle in this quadrant is 3 pi over 4. So one of my polar coordinates is p is equal to root 2, comma, 3 pi over 4. And then remember, there are other ways to represent this. Instead of going pi over 4 here, we could go coterminal angle, and go clockwise around the unit circle, which would be negative 5 pi over 4. So another way to represent this would be square root of 2, negative 5 pi over 4. And then remember, we can also do this with a negative radius. So if we did a negative radius, then our angle measurement would have to be 3 pi over 4 plus pi, so 7 pi over 4. So we would have negative square root of 2, 7 pi over 4. And then we could also do the coterminal angle for 7 pi over 4, which is going to be negative pi over 4. So that would be if we started here and went clockwise. So my last way to represent this is negative root 2, negative pi over 4. All right, pause the video, give these two a try, and then we will go through them together, and then you are done for today. All right, first one here, finding our r value. R is equal to square root of negative 1 squared plus negative square root of 3 squared. So r is equal to 1 plus the square root of 3 squared is 3, so 1 plus 3 is equal to 4. My radius is equal to 2. And then theta is going to be equal to tan inverse of negative square root of 3 divided by negative 1. So remember this here, since my x is less than 0 and my y is less than 0, this is in quadrant 3. So we are looking for our angle that has a tangent value of positive square root of 3 that's in quadrant 3. So that happens to be at the angle 4 pi over 3. So my polar point would be 2 comma 4 pi over 3. And then my last example for the day, we do this one here. R is equal to the square root of negative 3 over 2 squared plus root 3 over 2 squared. So if you do that math out, you will get this underneath here is the square root of 3. Honestly, I would use your calculator for this. It's going to save you a little bit of a headache. So r is equal to square root of 3, and then theta is equal to the tan inverse of root 3 over 2 divided by negative 3 over 2. That's kind of gross, but we go through it. These 2's cancel. We have root 3, and we're going to move that negative up here just because it's nicer. Negative root 3 over 3. Since my x is less than 0 and my y is greater than 0, this is in quadrant 2. And the angle in quadrant 2 that has a tangent value of negative root 3 over 3 is 5 pi over 6. So my polar coordinate is root 3, 5 pi over 6. All right, get some practice in with this. I promise this gets more intuitive the more that you practice. Feel free to reach out with questions. Always happy to help you guys out.